All right, our topic today is factor trinomials where the lead coefficient is greater than 1. Up until this point, basically everything that we have done has been where the lead coefficient is equal to 1. For example, x squared plus 7x plus 12. Okay, by the way, this is on your own paper, so you need to grab a sheet of paper here. X squared plus 7x plus 12. This is a 1x squared. The number that's in front of x squared is what we call the lead coefficient. Lead coefficient. And we kind of figured out a nice little, not trick, but a nice catch for doing this, where if you take 12, the constant, and you're looking for numbers that multiply to 12 that add up to 7. So 1 and 12, no. 2 and 6, no. 3 plus 4 is 7. And your answer is x plus 3 times x plus 4. Now that's a nice pattern. The problem is that it doesn't always work. What happens if your lead coefficient is not a 1? What if it's something bigger than that? For example, excuse me. Example, factor, and let's say 8x squared minus 10x plus 3. Now, first of all, you're going to see right away that if I try to factor the number 3, now I'm going to do this on the side, don't write this down. If I factor the number 3, well, the only possibilities are 1 and 3. There's no way for me to get the middle term of negative 10x using these two factors. So we have a problem here. And the issue is that, well, this 8 is going to be doing some things to your factors, so you can't ignore it. So when we multiply this, we're going to go back to the box. The first term, the x squared term, goes in the top left, 8x squared. The constant, positive 3, goes in the bottom right. And then the question is, how do we fill in these two squares? Well, the only thing that's going to be a little different about this problem is that instead of doing 3 for our product, it's not going to be 3, it's going to be 8 times 3. I'm going to take that 8 and multiply that by the 3. Okay, so we're on the side here. I'm going to do 8 times 3, which is 24. That's the number that I'm going to factor. Now we're looking for factors of 24 that add up to negative 10. So, and they both have to be the same sign. They have to be plus plus, or in this case minus minus. So 1 and 24, no. 2 and 12, no. 3 and 8, no. 4 and 6, 4 plus 6 is 10. So that means that negative 4 plus negative 6 is negative 10. That's what I want. So in my box, I'm going to put negative 4x and negative 6x. So here's the next problem that we come across. Well, before, when I looked at the top row, all I had to do was pull out an x, because they both had an x. And I can do that here. But it's not just an x. What else can I divide out of both of these values, both of these terms? See, I also have an 8 and I have a 4. This is not a 1x squared anymore, so it's not automatically x times x. Is it 4x times 2x? Is it 2x times 4x? Is it 1x times 8x? Is it 8x times 1x? I have all these possibilities and only one of them is right. One way to do this is to try to guess and check, but that could take a long time. So what we are going to do is we're going to take the top row and we're going to factor out the greatest common factor. The greatest common factor, or the GCF. what we call the GCF. So you're thinking, okay, x squared and x, I can take an x out of both of those. Now how about 8 and negative 4? What can I take out of both 8 and 4? What can I divide out? Well, 2 goes into both of these, that's true, but I want the biggest one, the greatest one, and that's 4. 4 goes into 8, and 4 goes into negative 4. Okay, so how do I fill out the rest of the box? Well, now I do the times table. 4x times what will get me 8x squared? Now 4 times 2 gives me 8, and then x times x gives me x squared. So that's going to be a 2x. 4x times what will give me negative 4x? That's going to be minus 1. 4x times negative 1 gives me negative 4x. Now down here, 2x times what will get me negative 6x? 2 times what gives me negative 6? Negative 3. Now I don't need to put an x here because I already have the x right there. 2x times negative 3 is negative 6x. Now to check it, how about negative 3 times negative 1? Does it give me the right constant, positive 3? Yes. So my factor pattern is 4x minus 3 times 2x minus 1. This is called the box method. And so we're going back to the box. There's really no quick, easy way to do this. But you're doing the box. And the only thing that's a little bit different is you multiply the lead coefficient and the constant to get to this number. You factor it. And then when you're pulling out the factors, it's not going to be x and x. It's going to be probably something else. You take out the GCF, the biggest numbers that you can divide out. Okay, let's do another example here. So that was example number, we'll say that was number 1 really, for factoring this. And we say the lead coefficient is bigger than 1. So here we go, example number 2. This is going to take you a little time. Remember the first time that we factored it was kind of confusing. By the end of it, think how good you were. Number 2 is 2a squared plus 13a plus 20. 2a squared plus 13a plus 20. Let's go ahead and set up a box. So we have 2a squared plus 20, and we're trying to get a combination here that adds up to 13a. Now the number we're going to multiply is not 20. It's the lead coefficient times 20. So 2 times 20, which is 40. We're looking for two numbers that multiply to 40 that add up to 13. 1 and 40? No. 2 times 20? No. 3? 3 doesn't go into it. How about 4 and 10? That's close. 4 plus 10 is 14, not 13. How about 5 and 8? Oh, 5 plus 8 is 13. Winner, winner. So let's take, in the boxes here, in the squares, we can put 5a plus 5a plus 8a. Now we're going to pull out the factors. Pull out the greatest common factor. Take the top row. I always start with the top row. So for the a squared in the a, we take out a. Now how about 2 and 5? Does anything go into 2 and 5 besides 1? And the answer to that is no. So this is just a 1a. So that's 1a. 1a times what gives me 2a squared? That's going to be a 2a. 1a times 2a is 2a squared. 1a times what gives me 5a? Just positive 5. I don't put the a down because I already have it right here. A times 5 is 5a. Now 2a times what gives me 8a? That would be a positive 4. And then 4 times 5, here's my check. Does it give me 20? Yes, it does. So this is good. My answer is a plus 4. I could put the 1 in front, but I don't usually do that. Whoops. A plus 4 times, the other factor is 2a plus 5. These are our factors.
Okay, and that's it for number 2. All right, I'm going to stop the video right now.
And that's the end of part 1, and we'll do a couple more examples in part 2.